All right, well, good morning, everyone. Welcome back to another exciting day in mathematics. Whoop, whoop. Warm-up 125 is on the screen as we are winding down to the last sessions of this school year for y'all. Your last mathematics sessions here at IHS for y'all. Let's go. So I'll give you some time for that. Copy and go. All right, send in your warm-up, please. And copy the agenda, warm-up 125, normal distributions. And for home play, I'm only giving you 10 problems tonight. Just kidding. So, be nice, my goodness. Ooh. Man, if those looks could talk. Anyways, it's not like if you can't do that on your bus ride. So how many hours are you going to take? Like 4 hours, 5 hours to get there? What time are you guys leaving? 6? Like, let's go. Yeah, it's like I think you guys stopped at the rest area for a little bit and stuff like that. All right, so once again, warm up 125, no more distributions, and I'm going to give you the afternoon off, I guess. Yeah, you guys are going to be off tomorrow. There you go, I'll give you that day off. Woo! Woo-hoo-hoo. What's that? Oh, that's true, yeah. You'll have tomorrow off. And Wednesday. Let's go. Anyways, copy that code. You're going to need access to the table for Z-scores. K9 NDE. K9 NDE. Today's a short session because we already did all the leg work on this. Today we're only moving on to applications, word problems. Yeah, let's go. Love word problems. All right. So, our objective for today, I can define and compute normal distribution. We're in the final session for normal distribution. We did a lot of that last week, finding the z-score and then finding the area under the normal curve. From there, we talked about variables. We're in the middle of continuous. Talked about normal or symmetrical, skewed left, skewed right. We talked about percentages. You guys know those by heart. And we know our formula for z-scores, yes? Yes, SEQ. This is the table that we use to find the z-score, and then from there get the decimal value, and then compute that into percentages. We did examples like this one, and we move on to today, which is this one. So copy this one so you can have as an example, please, on your paper. And it reads, example 1, a survey found that women spend an average of $146.21 on beauty products during the summer months. Assume the standard deviation is 29.44. Find the percentage of women who spend less than $160. Assume the variable is a normal distribution. Draw your area under the curve. All right, copy that. I'll give you some time, and then we'll work this one out and give you your final practice on these. Go. All right, we good? All right, so do me a favor, sketch a bell curve right underneath your standard or normal distribution. All right. So, your curve should look something like this. Whoa, kind of crooked, sorry. All right. So, let's break this down. It says, a survey found that women spend an average, or on average, 146.21. Tell your neighbor what that is. What is that according to our curve? All right. Good conversations. What is that, Joseph? What is it? Yes, the mean or mu. Label that mu or the mean. So that's 100. Let me move this down a little bit. $146.21. All right. Then it reads, on beauty products during the summer months, assume the standard deviation is 2944. So we have a standard deviation. 2944. Calculators calculate 146.21 plus 2944. What's our first standard deviation up? 175.65. All right. So that's our first standard deviation. How about below? 146.21 minus 29.44. 116.77. That's one standard deviation below. Okay. So far so good, yes? Then it says, find the percent, let me repeat that again, find the percent of women who spend less than 160. So look at your normal distribution. Where do you think 160 falls in between? Tell your neighbor, where were you marked the position of 160? And tell your neighbor, what is the name of 160 on the bell curve? What is the name of 160 on the bell curve? Joseph, pass someone. Chelsea, between where and where is 160 on the bell curve? 146 to 175. Okay, tell me where to stop. Right there. Okay, so mark it right there, guys. And tell your neighbor what is another name for that position. All right. So being that this is a spot in between these two values, this is what we call X. It's not exactly the Z, because Z we need to find a percentage under the curve. So, question. Do we have a mu? Yes. Do we have a standard deviation? Yes. Do we have an X? Yes. So what we need is a percentage. But what do we need in order for us to find the percentage under the curve? Think about it. What do we need to find the percentage under the curve? Chelsea, pass someone. Daisy, what do we need? A decimal, which comes from where? The Z-score. That is correct. Let's go. So write your formula. Z equals what? How do you find your Z-score? Tell your neighbor, please. How do you find your Z-score? Then Caleb's going to enlighten us. Z-score. doing this every morning, but now it's automatic. You know what? No, Areli's going to help you. Caleb, how about that? Areli, formula. Very good. X minus mu. That is correct. So to find our z, we subtract the number, which is 160, minus mu, which is, mu was 146.21. 146.21. Over standard deviation, which was 2944. So let's see, 160 minus 146.21, that gives us 1479, is that correct? Yes, no? No, 1379. Yeah? $13.79 divided by 2944, and that is, calculators, 0. What? 46. All right. So, do you guys know what to do with that z-score? 0.46. Tell your neighbor what to do for that in order for us to get our percentage. What do we need to do with that? Now, let me remind you in case you forgot. Before we did these, I gave you the z-score. Then you did what? And then what to get our percentage? Tell your neighbor. What do we do now with that? All right, good. Daisy, pass on one. Yeah, you find it on your table so you can find a decimal to make it into a percent. I sent the table over to your screen. Find me that decimal, please. Give some time. Go. All right. Well, what is the decimal value of 0.46? Mia Victoria, pass someone. Peyton, decimal value. Point what? Seven what? 2. Hands if you got that. So therefore, what is a percent under the curve, everyone? Percent under the curve is 67.72%. So let's answer the question. It says, find the percent of women who spend less than $160 over the summer. The percent, or be a little bit more direct about that. Women spend about 67.72% in beauty products over the summer. 10Q. Pretty straightforward, yes? From 1 to 5, how comfortable are you with that? 5 fours, 5 fours, okay. All right, so let me send you the screen so you can send me your notes. Give me a second. All right, move on to number 2, and it reads, Americans consume an average of 1.64 cups of coffee per day. Assume the variable is approximately normal distribution and standard deviation of 0.24 cups. If 500 individuals are selected, approximately how many will drink less than 1 cup of coffee per day? So, let me send this to your screen. Hold on. All right, so this one don't copy, but on your screen, I want you to label, look up, label me what is what of that problem on the screen according to the normal distribution bell curve. According to our normal distribution curve, what is what? What are they giving us there? All right, Peyton, pass them one. Chelsea, give us one label. What do I label what? .164 is a mu. Okay, I'll go with that. So I'll put 1.64 R mu. Pass them one. So standard deviation is 0.24. So calculators calculate. One standard deviation up, we should be at what? 1 point what? 188? About one standard deviation below? 140? About two standard deviations below? What is it? 116? About three standard deviations below. What is it? 0.92? Okay, now notice that I went three standard deviations over here to the negative side. Why? Because look up. What does it say here? They want to know people that drink how many? 1 cup per day. Or less than 1 cup. All right. So, with that said, I'll give you some time. Use your formula. Find me Z, X, mu, standard deviation. And by the way, before we move on, I know some of you are like making the question, Mr. Q, which one is our X, the 500 or the 1? Talk it over your neighbor. Tell your neighbor which one's going to be our X, the 500 or the 1. Now let me go back to the previous problem. Look up. Money, money, and money. Does it say, like, in regards to people? No, right? So therefore, tell your neighbor what our position would be, or the X would be. And who went last? Who? Was it Mia? No? I think it was. Pass someone? Joseph, which one is our X? 500 or 1? That is correct. 1, so that means our X. Tell me where to position this, guys. Pass someone, Joseph. Dylan, I'm starting at mu. Tell me where to go and where to stop. To the left? Yeah, around here. This is 1 cup, about right here. And now we need to find our z to get our area under the curve. So 1 minus 1.64 over 0.24. Who's got that number already? Negative 2.6. 2.6. So then go to your table and find me the decimal value of that at negative 2. Oh, let me send that screen to you. Areli, pass someone. Go. Diego, negative 2.6 in decimal form. 0. What? 67? 0.47. Hands, have you got that? Looks about right. So the area under the curve is 4.7. What is it? Point what? .0047. Ah. So that is what? 4.7%? 0.47%. 0.47%. Which it averages to what? What do you think it averages to? Not even 1%, it's 0.5%, right? All right. Write your statements. Let me send you the screen so you can send me your notes. All right, from 1 to 5, I'll come for you with applications. Normal distribution, yes? We got it, right? All right. So, look at these next two. Example Q, example super Q. Very similar. Extra practice, especially those of you that are following on YouTube. Do those for your extra practice. So I'm going to stop the video right here. See you guys later. Bye.